Hi all, in this video I'll show how you can calculate pi by hand using Machin's method. Now in my last video I derived Machin's equation, so check that out if you didn't, but in this video we'll go through his method on how he calculated pi to 100 decimal places, but obviously we won't be doing 100 decimal places for this video, otherwise it would take many months. So Machin's formula is pi over 4 is equal to 4 times arctan over 1/5 minus arctan 1 over 239. Now, what he did was, well, I'll write that out in series. So let's do the 4 times arctan of 105. So 4 times the arctan of 105 in the series is 1 over 5 minus 1 over 3, 1 over 5 cubed plus 1 over 5, 1 over 5 to the power of 5 minus 1 over 7, 1 over 5 to the power of 7 plus, and so on. Alright. Now, what Machin did was he calculated all these terms first. He then added them up. He then calculated all the positive. Then he calculated all the positive terms. He added those up, and then he calculated all the negative terms. He added those up, and he took them away from each other. So let's just do that. So, right. Normally a general, because arctan of x is equal to the summation of n to infinity. Sorry, that's not right. N equals 0 to infinity of negative 1 over n. Negative 1 negative 1 to the power of n over x over 2n plus 1 to x to the power of 2n plus 1. Okay, so we'll normally say this is the 0th term and this is the second term, but we'll name it in a different convention for ease of computing. So I'll call this A1, A3, A5, A7, and so forth. Alright, so what we can do is set up a table. Like so. So A1, what is A1? Well, A1 is 1 over 5, which is, and we'll call this is a decimal place, so 1 over 5 is just 0.2, so we'll put that there. Now each succeeding term to the power is a odd term, so that is just every other term is times a squared, which is 0.2 squared, and that equals 0.04. So this is good because it gives us an ease of computing those terms. So what will the next term be? So A3, that's 1 over 5 cubed. Well, that will be 0.04 times 0.2. So we'll get 0.08 there. Similarly for A over 5, it'll be 8 times 4, and that will be equal to 32. So you've got 2 places there plus the 3 here, so 0.0032. And for A7, we do that again, and that will be 32 times 4, which is equal to 128, so 0.000128. And for the A9, you can do A9 terms, etc. So if you do the A9 terms again, it'll be 4 times 128, and that will end up being, so 0.4 from that, 1, 2, 3, 4 from places there, it's 0.00 0.000512, and so on and so forth. Now, so Machin, he first computed the positive values first, the positive values of this series. So he computed that, the pair of 5 term, and then and so on and so forth. Okay, so let's do that. So do that. So again, A1 is a first positive term, and this is the decimal point, remember, so that's just 0.2. And for A5 over 5, now that is, again, 1 over 5 is just 0.2. So what is the 0.2 times 32, which is just equal to 0.00064. Now, we could compute the other terms, but for the purposes, like let's say we want to compute to pi to 5 digits. So this will be enough terms to compute 5 to those digits, because this series, or this formula here, converges quite fast compared to, say, the Nyla-Cantor-Leibniz series of pi over 4. So what he did then was he added these two, or he added heaps of terms because he did it to 100 decimal places. But so what we can do now is we add those two terms. So 6,4. So 20 that, so 0.200064. Now, what he did after that was he computed all the negative terms, and then we'll do that now. So control. All right. Now, the first negative term is 1 over 3, that, so A3 is 008. So we have A3 over 3. Now, we'll have to divide 0.008 by 3. So let's do that over here. So we'll set this up. And we can just put 0.8 like that. Just remembering it's that's point times 10 to the negative 2. So we'll just remember that. We can just move over the decimal places, but when we finalize the answer, we'll put it in the right place. So that, we'll put that decimal place up there. So 3 over 2, 3 goes to 2, so 2 times into 8, and then we'll have 6 here, plus 2 left over. We'll carry the 0 down, we'll have 20. 3 goes into 20 times, 3 goes into 26 times, so 6 times 3 is 18. So we'll write that there, so 6, take that away, we get 2, and we'll get the 0.266666, like so. Let's keep on repeating. So we'll do that to, say, yeah, so it's 0.2, yeah, so we'll do it to 9 decimal places, yeah, why not, 6666. Now we'll put that one extra on too. Alright, so 10 decimal places basically. Now we'll do, the next negative term is negative 1 over 7, times 1 over 5 to the power of 7. So we'll do that. So A7 over 7. Now again, we'll have to do some long division, and A7 is 0.0000128. So again, we'll just move the decimal place over, so 128. Actually, I should do this more neatly. So put the decimal, just imagine the decimal places there. So 1, 2, 8. Now it doesn't go into 1, so we'll carry that down. 7 goes into 12 once. Carry out that. So 7 is, that's 5. Drop down that. Now that will go into 58, 7, 8 is 56. So there, put the 56 there and take that away. 2, we'll drop down that. Gets a bit more room here. 7 goes into 22 times, so 14, 2, that goes into, so that's 6, again, drop that. Again, that will be 8, because 7, 8, so 56, 56, and that's 4, yep, 4. Drop that down, so 40, that will be 5. So 5 is 35, so 5. Drop another 0 down, so we don't have to do those. So 50, that will be 7 7s are 49, so 7 7s are 49. We get, drop that down, we get 1 left over, and get 1 there, and I won't carry on because that's 0.0 and plus, so 0 0 0. That will be 1 2 3 4 5 1 8 2 8 5. And yeah, so we won't worry about those extra numbers there. Okay. Now, what Machin did then was he added these up. So he added the negative terms up. So let's just whoops, I'll just leave that in. All right. So that's just 5. That is equal to 14. 7, 8, 9. 6 is another 14. So carry that over. 7, 8. So 6, 6, and 2, 0, 0. And remembering that's the decimal point there. So I think that's all good. Yep. Now, so we'll have to take that away from this because we've added up the positive terms and now we've added up the negative terms and we'll have to take it away. So let's do that. So we'll have 0.00266849445 take away 0.2000 0.20064, and we can put in those there. All right. Oh shit, I did that the wrong way around. Silly me. First mistake. Silly mistake. So take that away from this value. Did that wrong. That was silly. All right, so 0.00026684945. Okay. Put that on there. All right. Now take 3. 9, 9, 9, 10. All right, so we got 5 here. 5 there too. 9 take 9 is 0. 9 take 4 is 5 again. Borrow from there. 13 take 8 is another 5. So we'll have 1, 9, 9, 9. 15 take 6 is 9. So 9 take 6 is 3. 9 take 2 is 7. 9 take 0 is of course 9, and we got 1, so we end up with that. 1, 9, 7, 3, 9, 5, 5, 0, 5, 5. Now, because we've done all that, now we've got to take the 4 times that arctan, so that approximation of the arctan. So 4 times that. This is the, okay, so 0.1973955 times 4. Right, so 4 times 5 is 20, carry the 2, so 4 times 5 is 20 again, so 22, 4 times 0 is 2, 4 times 5 is 20 again, 22, carry that, 4 times 9 is 36, so 8, carry that, 4 times 3 is 12, we get plus 3 is 15, 4 times 7 is 28, so plus 1 is 29, 4 times 9 is 36, so plus 2 is 38, and 4 times 1 is 4, plus 3 is 7. So we'll get 0.7895820020. Now, he does the same procedure for the second term, so this minus arctan 1 over 239. Now, so I'll write that in. Arctan 1 over 239, right? So 1 over 239. Now, because that's a small number, this converges quite fast because you have 1 over 239 minus 1 over 239 over 1 over 239 cubed. So for how many decimal places we want, we can just ignore this term because it goes to 0 quite quickly. So we can just calculate this term, but of course Machin, he calculated the decimal places to 100 decimal places, so he would have used many of these terms and calculated that all out. But we'll do that now. So I'll go to the next page and we'll calculate 1 over 239, which will be our next, well, we won't need that long of a column, but anyway. So we'll call this B1, term B1. So 2, 3, I'll do this over here. So 239 into and neat. So 239 into 1. Well, it doesn't go into 1, so we'll just put like so. So 0. So 10. Yeah, it won't go into 10 obviously, so we'll carry that over. 100 won't go into that, so we'll carry that over into 1000. Now 239, we'll say we'll approximate 240. So 240 times 4 is 960. Take away 4, so we get 956. Yeah, 956. So 956. So that's 4. So, and we'll calculate it. So subtract all that. We get that'll be 44. Drop that. 0. So 440. It will only 239 will only go in 1 times there. So 239. Take that away, that will be, that's 201. Drop that other 0, so 210. Now we can just times 960 by 2, that is equal to what? 960, that'll be 1920. Take away the 8, so that's 1912. Yeah, 1912, so 1912. And that will equal to, what will that be? So I'll carry that out. So I'll borrow that. So that's 8, 1, 9, 10. That's 9. Yep. So 0 and 0. So that will be 8. Carry over that 1, so we've got 980. Again, that will 9239 will go in 4 times, so 956, and that is 24 when we subtract that. So again, we've got the 4 times, so, and we'll drop that 0. 240, well, 239 will only go in once, so 239, so 1 time there. Yeah, so that will be 1, and again we got 10, so that will go 0, 1, 0, 0. We'll go and there will be 1,000, and they'll go in 4 times again, so it's just repeating them. So with this, we've got 0.0041841,004, so that's 9, 10 places there. Now, like I said, because this series converges to 0 really, or the terms converge to 0 really fast, because we've got the cubed there, and then you've got the power of 5 for the next term. For how many decimal places we want, which I would say 5 or maybe 6, I don't know, 4 or 5 decimal places of pi. This will be, so the B3 term, I've calculated on paper before, I think it's around 73 or something like that, but it's way, so yeah, 73 here, but for the calculations of for our purposes, we won't do that. So now we'll have to take this value away from this, because we've calculated the 4 times arctan 1 over 5, take away the arctan, we've just calculated the approximation of arctan 1 over 239. So let's do that. Will it be better to do it up here? I'll zoom out a bit. No, yeah, it'll be better to do it up here. So we have 0.789582020 take away 0.0041841,004. Okay. Now, so that's 1, carry over that, so 10 over take away 4 is 6, 1 take away 0 is just 1, 2, 1 there, so 9, 7, 11 take 4 is 7, so can't take 7 from 8, so we've got 4, 17 take 8 is 9, 4 is 3, 9 take 4 is 5, 8, 7.0, so we end up with 0.78539799216. Now, of course, we have to we still got to incorporate this term, so that pi is over 4, so we've got to times that, so all this by 4. So we do that. I'll write it over here. 0, whoops, that's a weird looking 0 0.7853979 times 4. Alright. Now, 4 times 6 is 24, so 4 there, carry over 2, 4 times 1 is 4, plus 2 is 6, 4 times 2 is 8, 4 times 9 is 36, so 6 there, 3, 4 times 7 is 28, so 1, 3, 4 times 9 is 36, so 9, carry over 3, 4 times 3 is 12, plus 3 is 15, carry the 1, 4 times 5 is 20, so 1, so 4 times 8, did I carry 4, started carry over 2, 4 times 8 is 20, 4 times, my mind is blanking here, is 28, no, 32, sorry, I don't know why my mind went blank there. 4 times 8 is 32, plus 2 is 4, so 4 times 7 is 28, plus 3 is 31.3, because we get 4 times 0 is 0, plus 3 is plus 3 is 3, so, and this is pi, or approximation of pi, 3.14159, and if we round up this, 2, so we've just calculated pi by hand, so 3.141592, which is quite a good approximation of pi. So I hope you learned something. Thanks for watching.